Morning. Myself Prabharan J, working as an assistant professor in EC department at SNS College of Technology. In this lecture video, I am going to discuss about the topic is decade counter from digital electronics subject. Let us discuss. Here, a decay counter is a type of digital counter that occurs from 0 to 9. A total number of states is 10 states and then reset to 0, repeating the sequence. It is commonly implemented using flip-flops and is often used in digital clocks, frequency dividers and other digital systems. It has some of the key features, that is counting range counts from 0 to 9. That means overall state is 10, and it has reset function. It's automatically reset to 0 after reaching 9. And implementation typically built using 4 flip-flops, that is 2 power 4 equal to 16, but only 10 states are used. Total number of states are 2 power 4 equal to 16, but here only we are using 10 states. Next one is the format of output of the decade counter. Binary coded decimal, that means BCD is the most common output for decade counter. Yeah. These are the states of the state diagram of the decade counter. The this provided a this is the state diagram of the decade counter, and here I see a step by step explanation. First one is representation of state. Each oval represents a state of the counter. The states are labeled with a binary numbers. For example, 0 0 0 0 0 0 0 0 0 1 1 0 0 1 0 up to 1001, corresponding to the decimal count values 0 through 9. Next is the arrows between states represent transitions caused by the clock pulse. A clock pulse increments the count, causing the counter move from the one state to the next state. After reaching state 1001, that is decimal values 9, the counter transition back to 0000, decimal 0, completing the cycle. The state progress in a fixed sequence, that is 0 0 0 0 0 0 0 1 0 0 1 0 0 0 1 1 up to 0 0 0 0. The initial state is decimal 0, and final state is decimal 9. After 1001, the counter reset to 0000, and its application of state diagram is it will help design and analyze the logic required for implementing a decade counter using flip-flops and combinational logic circuit. It ensures that the counter cycles through exactly 10 states before resetting, as required in applications like digital clocks, even counter and frequency dividers. Next is, yeah, decade counter. This is the truth table of the decade counter. First one is 1, QD, QC, QB, QA is the output bit pattern, and decimal value is 0. up to 9. Okay. This is the logical diagram, and this is the timing diagram. The timing diagram of a decade counter shows the behavior of its bits like a Q3, Q1, Q3, Q2, Q1, Q0 over time as it transitions through its states in response to clock pulses. Clock signal. The clock is the input signal that drives the counter. A rising and falling edge in the clock triggers the state transition. The output signal like QA, QB, QC, QD, these are the binary outputs of the counter representing the count in binary form. Q0, that means QA. QA toggles with the every clock pulse. Q1 toggles with every 2 clock pulse. Q2 toggles every 4 clock pulse. Q3 toggles every 8 clock pulse. When the counter reaches 1001, which means QA equal to 1, QB equal to 0, QC equal to 0, QD equal to 1, decimal 9, all outputs reset to 0. Reset to 0 on the next clock pulse. Okay. Here the clock pulse has a series of altering high and low. Q0 toggles at every clock pulse. Q1 toggles as at every 2 clock pulse, second clock pulse, and QC which means QB QC QD toggles every fourth clock pulse, Q3 every eighth clock pulse. You can see here. Okay. These are the timing diagram. Assessment of this lecture says, what is BCD counter? Design synchronous decade counter using T flip flop. Difference between synchronous and asynchronous counter. Note it down. If you have any doubt, you can ask me through the comment. We will meet in next video. Thank you.